Hi, welcome to our guide on FairCap, the portable water testing kit. Today, we'll explore what FairCap is and how to use it effectively to test for fecal contamination in water samples. FairCap is a kit designed to detect fecal contamination in water samples. It's an interesting tool for ensuring water safety in communities and during emergencies. Let's take a closer look at the components of FairCap's portable lab for testing fecal contamination in water. First, we have the portable, lightweight USB-powered incubator. This incubator provides the ideal temperature for the growth of bacteria, ensuring accurate test results. Next, we have the small reusable plastic concentrating disc, along with the 0.45 micron 50 mm diameter paper filters. These components work together to concentrate and filter water samples, making them ready for testing. We also have the E. coli and coliform compact dry plastic Petri dishes. These dishes contain the necessary agar medium for bacterial growth, allowing us to visually detect the presence of harmful bacteria in water samples. In addition to these, you'll need a 50 ml syringe for collecting water samples, a pen for labeling, alcohol for sterilization, tissues for cleanliness, and tweezers for handling the components with precision. Now, let's walk through the steps of using FairCap to test water samples for fecal contamination. You may test natural water sources or treated water to measure the level of contamination or disinfection in the water. Each sample should be of at least 100 milliliters to follow international guidelines. And remember to ensure that the sample is taken following the proper protocols and kept in a closed, sterile container and kept in cold, less than 4 degrees Celsius, until tested, preferably within 24 hours. You might want to collect 1 liter of water per sample. Before beginning the test, wash your hands and clean the surface where you intend to conduct the water test. Using a tissue with alcohol, clean all the pieces needed to conduct the test. Clean the inner surface of the plastic concentrating disc, including the silicone ring seal. Disinfect the tweezers as well. Fill the 50 ml syringe with alcohol and empty it to let it dry. Dry the alcohol from every piece with a tissue or let them air dry for a few minutes. Take 50 milliliters of water from the water sample with the disinfected syringe. Using the syringe, place 1 milliliter of water, about 15 drops, into a new compact dry plate to humidify it first. Insert a 0.45 micron filter paper into the disinfected concentrating plastic disc and screw the disc's lid to close it. Ensure to place the paper filter with the gridded side facing up. Slowly insert the rest of the water inside the syringe into the concentrating disc by pressing the syringe. Repeat the last step to pass a total of 100 milliliters through the concentrating disc and paper filter. Open the concentrating disc and remove the paper filter with the clean tweezers. Insert the paper filter into the humidified compact dry plate. Remove any remaining water from the concentrating disc with a tissue and let it dry for future use. Label the plate with the location and date of the sample. Insert the Petri dish into the incubator with the lid down and ensure you can read the EC label correctly. Turn on the power of the incubator by connecting it to a USB power source, such as a power bank, wall, or car phone charger. Set the temperature to 38 degrees Celsius by pressing the set button for a couple of seconds and using the plus and minus signs to change the temperature. Let the incubator run for 14-16 hours. Finally, it is recommended to disinfect with alcohol all the parts of the kit used, syringe, tweezers, the concentrating plastic dish, before storage. After the 14 to 16 hour incubation period, it's time to interpret the results. Each colony represents bacterial growth in the water sample. The red-purple dots indicate coliform bacteria, which are not necessarily a sign of fecal contamination, but can indicate the level of disinfection in the water. However, the blue dots represent E. coli bacteria, which are a clear sign of fecal contamination. While E. coli bacteria themselves may not be pathogenic, their presence indicates contamination by fecal matter, which can carry harmful pathogens like bacteria and viruses. By counting the colonies, we can quantify the contamination per 100 milliliters of water sample. This allows us to assess the safety of the water source and take appropriate measures to ensure water quality and safety. Interpreting these results is crucial for understanding the microbial quality of the water and taking necessary actions to protect public health and safety. Please take into account that to follow the standard test, you need to filter 100 milliliter of water. But when too many colonies are present in the results of the test, we recommend to repeat the test with only 1 milliliter so the colonies can be easily counted, and several samples from different water sources are being tested. Ensure the cleanup and disinfection of the equipment between samples, and preferably start filtering the samples with lower expected contamination. In conclusion, VERCAP help us to detect fecal contamination in water. Thanks for watching.